is third quartile. So the difference between second quartile, that is median, and the third quartile, that is third quartile, is say 74, 84, 94, around 34. But if you look at the fourth quartile, max value is the fourth quartile. So the difference between third and fourth quartile, that is say 126. So the difference between first quartile and second quartile is around 29. Zeroth, the starting value to first quartile, 0 to 25 is around 31. First quartile is 25 to median 50 is around 25. Then 50 to 75 is around 34. And third quartile, that is 75 to maximum 100, is 126. So if you look at the data from 75 to 100, there is a huge difference. There are huge numbers when compared to the remaining. So it itself shows that there are some outliers within the data. Okay, that is towards the upper boundary. So if you look at experience, the minimum value is -3. So we cannot have any individual with -3 as experience. If he is a fresher, okay, the minimum experience would be 0, but it cannot be -3. So what does that mean is there are some outliers in the income column and also the experience column. But what we decided is we are trying to work on decision tree, so we will not tamper with the outlier data. We will keep it, though it is noticed that there are some outliers within the data, but still we will not manipulate it. We will keep it as it is, and we will build a model and see how our decision tree can handle outliers without our involvement. Okay, so let us try to go further. Summaries. Okay, so let us read this second file. So the file is copied. We have only three columns, that is id, inforec, and loan. Loan is our dependent attribute or column or variable. Inforec is how the bank has contacted the client, whether email or phone. Phone is not visible, but as we go further, it is there. So this inforec column means info required. A column has two levels or classes or categories. One is email, second one is phone. Let us quickly look at the dimensions. 5,000 records and 3 columns. So there are no change in the number of rows. Okay, that is observations. It is fine. We can club first and second tables without an issue. And we have 8 and 3 columns. And ID column is the primary column. Okay, let us look at the number of values which are not present. NS missing values, so absolutely 0, so nothing to done. Okay, everything is neatly arranged. The table is neatly arranged. Let us look at the structure function. Data frame, 5,000 observations and 3 variables, id, inforec, and loan. We have one column which is character in nature, so we can work it out later how to do it. Let us see from here slowly. They Okay, manipulation starts. Please concentrate. The data is being copied, so we will be patient. It's taking a little bit longer time. We can interrupt, we can stop, or by clicking on this red button, but we will not tamper it. Let it be. Let us see how much time it takes. I think there is another function, another file executing simultaneously. something, that is a reason it is stopped. Okay, let me close this down if possible. Which one is this? FRA. Okay. 2 minutes, students. Let me close it down. Okay, successfully closed that. Let me also close it. Okay, because that is closed, so this is working. So simultaneously both are executing. That's the reason it is taking some time. So normally it will not take that much of time. So let us look at the third table. We have copied that into R. So again it has say three columns: ID, month, and monthly spending. So this is credit card details. So we have ID column, month. So one represents January monthly value and all. We also have the dimensions. So it has 60,000 records and three columns, and missing values we have 1768, which is a minute number, very small number that we can handle. Now, as we said, when we have first table, second table 5,000 records, and the third table 60,000 records, we cannot work on that. So what we are supposed to do is we are supposed to manipulate this. So what we do is we will bring this 60,000 records to close to 5,000 records. Now you can ask me how can we bring? So should we remove certain number of rows? No, we will not remove any row, but we will do a small trick. We will apply a small logic. So the logic is we have for each individual. So at the same time, let me also show you, if we have head, we should also have tail, right? So let me also show you the tail value. So we have around, say, every 12 months ID is the first. Okay, month one is January, monthly value is monthly spending credit card value. Similarly, if we execute tail, so what happens is ID, see 12 means the last month and how much did they spend in the last month. Okay, so we have for each individual ID 12 months of credit card spending. Okay, for first say applicant from January, February, March till the end of the year, 12 months credit card spending. Then second applicant from January, December to end, okay, year end. For third individual, same 12 months, so on so forth. So what I mean to say is for each individual we have 12, okay, rows, means each row representing 12 months of a year and 12 months of credit card monthly spending. So what we do is we will take these 12 months for each applicant. We will, okay, simply find an average. So for the first applicant we have 12 months, right? So we will calculate the mean, means we will sum all the 12 months values for that one applicant, ID1. Okay, 12 months values we will sum and we will divide it by 12. Similarly, go to the second ID. We will, okay, take the 12 months credit card spending and we will divide that sum by 12. So in this fashion, what happens is 60,000 records are there. If we have 5,000 IDs, 60,000 divided by 5,000 is 12. Means there are 12 months of data. So in the other way, what we can do is, if 60,000 records are there, if we divide it by 12 months, we have 5,000 records. So we can have 5,000 values, each value corresponding to the mean credit card spending of one applicant, so on so forth. So by doing this, we are not losing any data. The only thing what we are doing is, in place of monthly, so in place of monthly spending, we are taking average annual spending, that's all. But without doing this, we cannot proceed. That's the only way we have got. So whether we like it or we don't like it, we need to proceed in this manner. So how to do it? Let me show you. Let me run the structure function again. We have integer and numeric value. So what I do is, I will take ID and month, which I convert it as factor. So in the first class we have seen how to convert any data into a factor by using the keyword as dot factor. So use as dot factor cc dollar $id in the file cc, go to the id column, convert that into factor with the help of as dot factor, store it into the same file cc with the column name id. That is what row 52 is saying. So we will transform id into factor. I will again explain you. What we are doing is, we are going to the cc file, credit card file. We are taking the month, that is the second column. We are converting that into a factor with the help of hash dot factor, and we are storing into the same file with the same name, month. So we are not changing the file nor the column heading, but what we are doing is, from integer we are making it a factor. Okay, so let me execute the 53rd row. Now once I convert id and month into factors, let us again run structure. So if you see, initially ID and month were integer in nature. Now they have become factor in nature. So now why are we converting integers into factors is, when you have a classification problem. As I said, loan is our dependent attribute. So 0 means person who has applied for a loan and loan was not given because of his credit rating. 1 represents an individual whose credit rating is good, or whose repayment schedule in the previous loan was good, and the bank, okay, gave him a second loan, okay, or sanctioned him a loan. So when we have the output in the form of 0 or 1, it is a classification problem. So, and we are using decision tree algorithm. So when decision tree algorithm is used on a classification problem, what we require as the end data type of each and every column is a factor. So when, again I'm repeating, when the problem is a classification type and the algorithm is decision tree, what we require at the end, okay, each and every column's data type is factor. Remember this. Okay, that is the reason we are slowly converting, okay, integers into factors, slowly, one by one. There are few which are already character in nature. We can convert them easily. The ones which are stored as integers and factors, slowly we will convert one by one. So in this process, the first thing what we did is, we converted id and month from integer to factor. Okay, at the end we should convert each and every column, but we will go one by one. So there is a certain process. Now once id and month are converted into factors, what we do is, we will try to use the same data, monthly data for each ID. We will collect all the 12 values representing 12 months of credit card spending, and we will apply a mean function on that. Okay, that is what we are doing. So let me first write a mean function, how to calculate mean. So this is how I am trying to calculate function. Or if you are not okay thorough with writing these functions, so there is no need for this. What you can do is, in place of this, you can simply write mean. That's all. There is a inbuilt function called mean in R which does the same thing. You can simply write mean over there. Okay, so that is what you are supposed to do, because some students ask me, sir, can we write our own user defined function? So I show them like this. That's all. So if you are not okay, if you are asking me, sir, why to complicate the things, there is no need to complicate. Simply you can remove na and you can write mean. Okay, so going further, what we are doing is we are applying a tapply function here. So tapply function, as you know, has three okay input values or arguments. The first is the numeric, that is the monthly column. Second is ID we are taking. Third is mean we are calculating. So we are picking up 12 months of data for each ID. We are applying the mean function. Now, why we are taking sequences, as we have 5,000 records. Okay, students, as we have 5,000 records, so starting with 1, ending with 5, say 5,000, with a difference of 1, means 1, 2, 3, 4, 5 are printed till 5,000. So, this I will take as the ID column, and tapply will calculate the mean values for each ID, okay, person. So let me call it CC average. If you are not following me, don't worry. Once you get the output, I will again repeat. So let me execute this. Head I am executing. So this is the reason I said, okay, why again sequence function we are using for this first column. So what I do is, now I change the heading to ID, because in table 1 we have ID column, in table 2 we have ID column, so even in table 3 we require an ID column. So to have that ID column, I am using sequence of 1 comma 5,000 comma 1. So 1 to 5,000 I am printing the values in a sequence, but say unfortunately the header what we got is something different. So what I do is, I simply use the names function and change the header to ID, so that I will have ID column and the same values in table 1, table 2, table 3, so that I can use it as a primary column and I can merge them. So let me also look at the dimensions. See, initially it was 60,000 records and three columns. As we have okay manipulated the data from 60,000, we have brought it to 5,000. But in place of three columns, ID, month, and monthly spending, we have got only two columns. So as I am not happy with the names of the columns, what I do is I make use of the names function followed by the table name. I assign new names to each column. The first column I am putting as ID, second column I am giving the name as CC average. Okay. Once I assign the names as ID and CC average. Now you can execute head again, so that you will have neatly polished data appearing. So this is the reason I have applied tapply, and for ID column I am creating, to create the ID column I have used a sequence function, and I have assigned names to it later. Okay. Let us run the structure function once again. So what we have is ID and numeric column has the data type number or numeric. So CC average cannot be a factor, but ID column can be a factor. So what I do is I again go to CC average column. In that I have ID column stored as numeric. What I do is with the help of as dot factor, I convert it into a factor, storing it in the same file with the same name ID. So I am not changing the name of the file nor the column name. What I am changing is only the data type of ID column from numeric to factor. That is what I am doing in row 69. Let us quickly execute the summary function. So summary function, look at the mean and median. Mean is 19, median is 25. Though there is a slight difference between mean and median values, but still the third quartile value is close to median, but the max value is very far from the third quartile value. So what we can assume is the difference between first and second quartile is less. The distance between median, that is second quartile, and the third quartile is also less, but the distance between third quartile and the fourth quartile, that is the maximum value, is high. So there might be outliers present in the outer boundary side or the higher boundary side. Okay, so this is what we can assume by looking at the summary data, but still, as we decided that we will not tamper with the outliers present, we will not touch it, we will move further. So let me look at the structure again. As I said, ID has become factor, and CC average, that is credit card spending, yearly credit card spending average data, is now numeric. Okay, the dimensions are 5002 columns. They are fine, so there is no need to touch anything. So if at all you have 4 GB or smaller memory space, what you can do is CC, we don't require it because it is already stored. So in the form of CC average, so we can delete the first table, that is the third table that we copied. Okay, CC, so that you can free up some memory space. Okay, students, now let us look at the fourth table. So we have around 20,000 records and 3 columns. Again, we have ID, variable, and value. What is this variable? Is suppose if a bank is maintaining some savings account, some fixed deposits, some trading account, or some other account. So these represents the type of account for each ID, and whether that individual ID has that particular account, okay, in the bank or not. Suppose if we look at ID1, the type of account is securities and he has that account. For ID2, again the type of account is securities, he has that account. Third, fourth, five, six, they are not the type of security. Okay, sorry, they are the type of security, but they don't have the account. So 3, 4, 5, 6 IDs, they don't have the security account. Similarly, there are 3 more types. This is what it represents. So let me look at the ID, variable, and value. ID is again stored as integer, so keep a small logic, columns like year, month, then say weekdays, ID, city names. These are some of the columns which, okay, ultimately should be stored in factor format. They cannot be numeric. Though IDs are represented in the form of 1, 2, 3, 4, they are not numeric values. They are ultimately factors. So ID, month, year, city names, week names, weekdays names. So these all, okay, become factors. That is the reason id is stored as integer, we will convert that into factor, whereas value is also consisting of 1 and 0. 1 is there is a security account, there is x account, there is y account. 0 represents there is no security account, there is no xyz account. So when we have only two outputs, 1 or 0, even that particular column, that is the value column, can be converted into factor. So here id and value will be converted into factors. And so the variable is already, it is in a character which is a form of factor, so there is nothing to worry about variable. So let us try to convert the first and the third columns, id and value, into factors. Once we convert them both, let us look at the summary function. So summary, looking at the summary function, we can easily identify that what type of values they consist of. Okay. Somehow today my system is lagging. Okay. Hanging. Let me check it out after this class because I don't want to tamper it now. If I touch it, then it will take some time. Okay, students. So let it take its time. So in the meanwhile, I will take some doubts from your end. So if you have some doubts, please raise it. Gauri, it is a little bit difficult for you to work with me because there are some packages that needs to be installed. It will take some time, but certainly after this class, you will certainly get all the notes today, so that tomorrow, day after, and day after, you can practice. Okay. Because if you start practicing with me, your total attention will be on the execution of the code rather than uh, knowing why we used t apply, why we converted into factors. So mostly you will be concentrating on whether the code executed or not. See, code, if your code is written in a correct fashion, and if the software is okay, original working fine, then anyhow you will get the output. So don't worry about the output, but I want you to concentrate. Okay. Let me check whether my, okay. So it is taking some time. I don't know why. I might be some corrupt file is there or something, but I'll check after this class, because if I touch it now, it will, if okay, if it starts updating and all, then our time will be lost. So if you look at value, we have 0 and 1, and there are some na values also. Okay. So still we have not touched the 20,000 records. What we did is we only manipulated with the data type of two columns, that is id and value. That's all. But still it is having 20,000 records. So let me go and look at the dim function again. See, 20,000 and three columns. So now we will try to do how to bring them. So for this, let me see if I can open an Excel sheet. Okay, because Excel sheet will help you in understand the concept quickly. Because yesterday I was trying to show you the file is not showing. That's the reason I am little bit apprehensive. But let me check it now. Okay, students, for a moment I am stopping the sharing of the R file. I will share you the Excel. Okay, so can you see? I hope you can all see now. So what happened is, in this file, let us say we have something called id, variable, and value. Okay. Let us say we have ID1, 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 ID1. Then let me also go with 2. Okay. Let us say we have some securities account. Let me copy this. Uh, okay, let me copy this, not an issue. Let us say some savings account, then some fixed account. So I'm taking some random numbers, then securities FD. Okay, some CC account, let us say. So what happened is, for each individual, let us say the first individual has a security account, he also has a savings account, no fixed account, no CC account. So for ID2 there is no securities account, he has a savings account, he has a fixed account, no CC account. Okay students, so this is how the data is spread. So for each ID we have four say rows. So if you have 5,000 IDs, 5,000 into 4 is 20,000 rows. That is what it is showing. Okay. So what I do is, I have a function called cast in R. What does this casting function does is, it keeps this ID as it is. Okay. So let the ID be like this. What it does is, these, okay, variable names will become columns. So the first column will be ID, there is no change in it. Okay. So second column heading will become securities, third column heading will become savings, then fourth column will be fixed, then fifth column will be CC. So as we have seen, we have two IDs. For the ID1, we have securities account, savings account. There are no fixed and CC account. So let me write 1 for securities, savings, 0 for CC and fixed. And for ID2, we have only savings and fixed, and the remaining two, that is CC and securities, it is 0. So if you count here, we have 1, 2, 3, 4, 5, 6, 7, 8 rows. If you count here, we have only 2 rows. So this is how we are reducing the number of rows, and the number of columns initially were 3. Now it has come to 5. But though the values are ones and zeros, it is acceptable. When new columns are created, and they contain ones and zeros, it is easy to handle them. Okay. So this is called casting. Casting means reducing the number of rows and increasing the number of columns without losing any data, especially the data is in the form of ones and zeros. Okay. This concept is called casting. Again, I am going to repeat. What is casting is reducing the number of rows, okay, thereby increasing the number of columns. Because when we say we are not supposed to lose any data, so when you cut down the number of rows, so naturally the number of columns will increase. So cutting the number of rows, increasing the number of columns without losing any data, this concept is called casting. Okay. Similarly, if we have more number of columns and we want to reduce them without losing any data, though we can do it by increasing the number of rows, reducing the number of columns, increasing the number of rows. That concept is called melting. Okay. So we will be now applying the casting technique. So let us go back. I will share back our R screen. Please hold on for a moment. Okay, students. So as I said, we have, okay, reshape package. If you don't have that package, please install that. Okay, simply install dot packages reshape. You can install the package. Once the package is installed, you can activate the package with the help of library or required function. Required function, I mostly use library, but if you want, you can also use require. So what I do is I take the cast function. The name of that file is other accounts. ID versus variable. So ID will be your row value, row heading. Then variable will become the new column heading, and the intersection of this ID and variable will be your value, whether that person has that account or not. Okay, so store it into a new column name, so that, okay, I didn't execute the library. Okay, so it is executing. So let us look at the head of the transform. So initially we had like ID variable values like this. Okay, we had the data stored in this format. Let us execute head again. So ID, CC, CD, online securities, these are the different types of accounts in the branch. Let us also look at the dimensions. See, we had 20,000 records and 3 columns. Now we have 5,000 records and 5 columns. So a quick recap. We copied the data, first file and second file. There is absolutely no change to be done except trying to input, okay, or input some values where they are null. Okay. Then in the third table, we copied. It had 60,000 records. So for each ID, 12 months of credit card spending is given. So we take a mean of all those 12 months for each ID, and we will come up with a single value. So we can easily come up with 5,000 records for the third table. Then for that we will use tapply function. Then for the fourth table, what we do is we use casting. So casting means decreasing the number of rows, increasing the number of columns without losing any data. So new columns are created. Okay, casting can be applied whenever you have zeros and ones in the newly built up columns. Okay, then we will try to merge these four tables one by one. Okay, as I said, if you have n tables, you can use n minus 1 times the merge function. So we have 4 tables, we will use 3 times the merge function. We will merge first and second table with the output of first and second merge table. We will merge the third table with 1 2 3 merging. We will merge the fourth table. This is how we will do. Okay, students. So before going for merging, I just want to ask you whether you are through with this concept, or is there any, okay, thing that I need to repeat. Any doubts, please ask me. See, because if you have doubts and all, you will not be able to understand the coming logic. Though this concept is not that difficult to understand, but a small gap will not help us. Okay, that's the reason I am asking. If you have any doubt, ask me. I'm waiting and I can clarify your doubt. Okay. So as most of you, it seems that you have understood. So what we do is we will move further. So let us take a small break here. Now it is 8:06. So we will meet by 8:12. Please be back by 8:12. Okay. Don't take much time. Please come back by 8:12. Okay, students, I am back. So, hope you all are back. So, let us start joining the tables, merging the tables. So, as I said, we will take the first two tables. We will treat the first table as X, the second table as Y. In both the tables, we have the ID column. Based on that, we will do an outer merge. So you know that outer merge is done with the help of the argument all is equal to true. So let us call this merged tables of 1 and 2, the merged table, we call it uniform. So execute the table and execute head function. So the first two tables are merged. So the first table had 8 columns, second table had 3 columns. So ID column uh, was present in our ID column is present in both the tables. So one ID column will be removed, only one will be left. So 8 plus 3 minus 1, it is around 10 columns we should have. So ID, age, experience, income, zip, family, education, mortgage, and CC average. Okay, sorry. In the second, we had how many? Okay, it's CC average, right? So CC average has only two, say only two columns. Okay, not three, only two columns. That is ID and CC average. That is the reason 8 plus 2, 10 minus 1, we have 9 columns. Okay, so that we can find in the merged table of 1 and 2. Okay, we have 9 columns. Now what we will do is we will go and merge this 9 columns with the second table. Accounts is fourth table, I think. Okay, so we have five columns in the fourth table. So let us merge it again execute the head function. So let us look at the number of columns in it. So we have 10, 9 plus 5, 14 minus 1, it should be 13. Hope it is 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have around 13 columns. So we have merged first, second. With the merged of first and second, we merge the third. Now with merged, okay, 1, 2, 3, we will merge the fourth table. So fourth table has again 3 columns. So 13 plus 3, 16 minus 1. 1 is the ID column, extra ID column that we are removing. So let us execute the dim. So we have 5000 records and 15 columns. These are the 15 columns that we have. Let me execute the head function again. So we have ID, age, experience, income, zip, family, education, mortgage, CC, average. Then we have 4 accounts: CC, CD, online securities, Inforec, and loan. So from ID to Inforec, we have the independent attributes, and loan is the dependent attribute. So it is in a data dot frame structure, 5000 observations, rows, and 15 columns. These are the names of the columns. These are the data types of each column and the first 10 sample values. So if you look at this from CC, CD, online securities, Inforec, these 5 columns are in okay character data type, and the remaining 10 are in integer. Are specific, 9 are in integer, and CC average is in numeric. Okay, so integer and numeric are of the same type, so there is not much difference between them. So what we are supposed to do is from 15, 5 are already in character. They can be easily converted into factors with the help of as dot factor. Now what we are supposed to do is, our concentrate is how to, okay, transform the remaining 10 which are stored in the form of integer or numeric into factors. This is an important job which is in front of us. So starting with this, the first thing what we will do is, we have certain NA values in our data set. We will be working on that missing values. Then there are some attributes or variables or columns which add no value, which add zero value to the model, like ID, zip, so on and so forth. We will try to remove them. Third one, there are some columns which are totally dependent on other columns. We call it as, they are highly correlated columns. So correlation between attributes is not at all, okay, required. Okay, it is not at all accepted. Okay, why? Because they are like friends sitting in an exam and writing. So when friends sit together and write, they chit chat, they slowly share the knowledge and write. That's what we don't want. So we want them to be independent. We want them to sit at a safe distance and write the exam, so that they can concentrate on their own paper. So what we do is, we execute COR. That is what we are going to, that is how we are going to find the correlation value between the different attributes. So correlation can be identified only for numeric attributes. So we will first segregate those numeric attributes and apply the correlation function, that is COR function. If at all there are some dependencies, so if the value, okay, is very high, then what we can say is, they are dependent on each other. So we will drop some of the attributes. So this is what we are going to do in the immediate steps. So don't worry, we will go step by step. You will understand, because you are doing it for the first time. You may get little confused, but nothing to worry. It happens to each one of us. So concentrate. Once it is done, then you go through it once again, twice, thrice. You will slowly understand. Okay, if at all you are not still understanding, you can ask me. I'm here to help you out. So first of all, we will know the number of values which are null, okay, which are missing. So 2570 cells are missing. So the total is 15 into 5000, that is around 75,000 cells are there in total, out of which 2570 are missing, so less than 0.03. Okay, so hardly, close to approximately 0.03, so which can be easily imputed. So for that, let us start with one by one step. So first what we do is, this character attributes what we have, we will try to transform them into factors, because that is the easiest job that we can do. So we will start from there. So execute the structure function. So from CCCD, online securities inforec, which were stored as characters, are now transformed, converted into factors. Then how to fill the NA values, null values are, okay. So we install DMWR package. DMWR has been updated with DMWR2. So you can install the package. I have the package, so I am not installing it, I am activating it. So let me activate DMWR2 package. It is getting activated. The red circle what you find is Okay, it is executing. So let me also run the search function to make sure that this particular package is activated. So if you look at the second position, it is DMWR2. So the package is activated. Now let us see how we can fill these values which are missing. So in DMWR2 package, we have a function called KNN imputation. So it has again three arguments. The first one is the data set. Second one is k is equal to 10. Method is equal to median. Meth means method is equal to median. We try to assign a new name to this, that is univ2. So we have worked on this, how this KNN imputation works. I will quickly recap what or how does it work. Suppose we have 100 rows. Out of these 100 rows, one row is having a null value. Okay, the value is uh, not present over there. So what we do is leaving that the remaining 99 rows, out of the 99 rows we will identify 10 rows because k is equal to 10. So from the remaining 99 rows we will identify 10 rows which are very similar to the row which is having the null value. Okay, so out of 100, one row is having the null value, missing value. So apart from that, the remaining 99 rows are taken. From those 99 rows we will, okay, identify 10 rows which are very close, which are very similar to the row which is having the null value. So once identified those 10 rows, we will apply the median function on those 10 rows only. We will get one median value that we will replace in the null value place. Okay, so we will replace that value in the null value place. This is how KNN imputation works. So KNN imputation works on the principle of KNN algorithm, and this algorithm is one of the most sought after, okay, algorithm. Its principle is very simple. Once we go there, okay, we will try to work on that, so we will not deviate from our decision trees at this moment. So DMWR2 package has KNN imputation function. It takes the data set which is having the null values, missing values. We take k is equal to 10. So there is no hard and fast rule that it is only to be k is equal to 10. You can use k is equal to 9, 8, 11, 12, but k is equal to 10 is a standard method. So I am using k is equal to 10, and you can also use method is equal to mean median mode, but I think median is the say more standardized version than mean and mode. So I am using method is equal to median, and I am assigning it a new name called univ2. So let me execute this. So it is executing. Let us take a moment. So from 75,000 cells, it has to find out these 2570 cells where they are present, then apply the KNN imputation technique. So it will take some time, but as I said, there is a lag in my laptop, so it is taking little bit more time. Usually it will not take this much of time. It will do it in say 15-20 seconds hardly. But so in the meanwhile, small recap. Once merged these four tables, we will identify certain columns which are in the character data type, we will convert them into factors directly. The remaining numeric we need to convert. So before converting, we will handing the null values, missing values. So for that, we will use KNN imputation function in DMWR2 package. DMWR2 package is the latest package that we have. Initially it was DMWR. So KNN imputation function has three arguments. One is the data set itself. Second one is k is equal to 10, and the third method is equal to median. So we will take the closest 10 rows. We will apply the median on those 10 rows. We will get one value that we will replace the missing value. Okay. Why it is taking so much time? If I interrupt also, okay. Hmm. If I interrupt, then I need to start from scratch. That is again a second issue. So now let us try to look at the NA values, missing values in our data set. So the new data set is UNIV2. See, it is now 0. So initially the data set name was Univcom. It had 2570, 2570 missing cells. Once we have applied KNN imputation on Univcom and changed the name to Univ2, so the latest Univ2 package has 0 missing values. All the missing values are now filled up. But in this process, there might be some issues cropping up. Like I will show you practically. Which one? Okay. So if you look at family, so as I said, family cannot have 0 0.5, 2.5, 6.5. Either it will be 1, 2, 3, 4, 6, 7, 8, 9, so on so forth. Only integer values. But in this process, what we have got is family as 2.5. So what we are supposed to do is ceiling or floor function. So you know what is ceiling or floor function. Ceiling is nothing but the immediate upper integer value. Floor is immediate lower integer value. So if you take ceiling of 2.5, it would be 3. If we take floor of 2.5, it would be 2. So probably I will go with the ceiling function rather than the floor. Now it is not fixed that you should always go with ceiling. It depends on your choice. Okay. So I'm going for ceiling function. Ceiling data set name dollar family, the column name. We are storing into the same data set with the same column name. Okay. Similarly, in the bottom, we will observe some changes in the education. So even I apply the ceiling function for the education. Now after executing run, you will find that these discrepancies that have been generated while say pre-processing the data are lost. Okay, students. So you look into the family. So there are no 2.5, so on so forth. All are now 1, 2, 3, 4. So this is how you have to keep a close eye on the data that you are trying to manipulate. These small glitches will cause some inconsistencies or inaccuracies. So you should be very careful. This is called eye for detail. Okay. So let us look at the structure function once again. So there are some functions that you need to run very often, okay, frequently, so that you will understand in which direction we are progressing. So still we have only 5 factor columns. The remaining are numeric and integer. We have a long way to go. So let us see what we can do in the next phase. So we will use sapply function to find the number of categories or levels or classes in each dimension or in each column. So what do you mean by factor? Say the categories levels is, suppose gender is the column. You have male, female. Suppose it is city is the name of the column. We have certain cities like Delhi, Bombay, Calcutta, so on so forth. They are the say levels, classes, or categories. So if you want to identify how many levels or classes or categories are present in each and every column of the data frame that we are working with, so there is no need to write the same table function again and again. So table function is the most widely used function. So there is no need to write table function again and again. You can use a supply function. Once it will give us the output. So how does this supply function work? We have learned it while learning R. You take the data set followed by okay your user defined function. So what we used is function of x. So what is this function of x is the first column will come. Let me write names function here. Names of univ 2. So function of x means your id column will be replacing this x. Okay. Function of id. Then it goes into the length of unique of id. So you know what is unique. It is the unique values. Length function counts. So you will get under id how many unique values are there. Once it counts the unique values in id column, then it will move okay forward. Then age will replace x function of age, then length of unique of age. Slowly it will start moving further till it reaches the last column, that is loan. This is how a supply function works. Again, I request each one of you to practice. So when I execute this function, see id column, no two rows should have the same IDs. So we have 5,000 rows, we have 5,000 unique values. So age has 79 categories, experience has 82 categories, income has 259 categories, so on so forth. Loan has two categories, that is 0 and 1. Got it? So this is how a supply function can be executed on the number of columns simultaneously to get the output. If at all we don't have the supply function, what we are supposed to do is use the same table of univ $2 age, table of univ $2 experience, table of univ $2 income. In the similar fashion, you should start from id till univ $2, okay, univ 2 table of univ $2 loan. So you need to write 15 times the same command function again and again, which looks very awkward. That's the reason we have cutting down on that, and we are writing or using the supply function. Now here we need to go and work on some other concept. Okay. Let me check whether I can copy the structure data into R, into Excel, so that there is no need for us to shift between Excel and R. I hope it will take. Okay. So I will paste the data here. Good. So now what you do, look or we do find is family is stored in the numeric data type. Education is stored in the numeric data type. Mortgage is stored in the numeric. So let us not look into mortgage. We will look at education, family. Okay. So they are stored as numeric attributes, but family has only four, uh, say categories. Let me write here. family has four categories, education has three categories, and loan is also stored as integer, which has two categories. Okay, participants. So now, what is the link between these three and the others? So when we talk about some attributes which are stored in the numeric format, okay, we have to divide it into two categories under numeric. Okay, I'm not talking about factor. I am only talking about integers and numeric columns. So the first one, can I get a shape here? Uh, okay. See, the first category is those attributes which are having less than 10 levels. Okay. And the second category are the ones which are having more than 10 levels. Let me write here, more than 10 levels. So in numeric, okay, columns like ID, age, experience, income, zip, family, education, mortgage, CC, average, and loan, we have few attributes which are having less than 10 levels, few attributes which are having more than 10 levels. So less than 10 level attributes are family, education, loan, and the remaining all are more than 10 levels. So why we are segregating is, when we have levels less than 10, those stored as numeric, they can be directly converted into factors. Directly converted into factors. Okay, which are those which are having, okay, less than 10 levels and stored as numerics. But there are few, okay, which are having more than 10 levels like age, experience, income, mortgage, CC, average, where the number of levels are more than 10 and they are stored as numeric. So we cannot convert them directly, but we should somehow convert them into factors. Though we cannot do it directly like the other case, but ultimately we should convert. So first we will deal with those attributes which are having less than 10 levels and be converted directly, which are stored as numeric. Now, what are they? They are family, education, and loan. Because family has four levels, education has three, and loan has two, but still they are stored as numeric and integer. Okay, or integer. So let me quickly move back to our art session, our art studio, so that I can show you the code how to do this. So we will proceed with this. So you need $2 family. Okay, let me not, okay, confuse you with new syntaxes. Let me use the old syntax. You need $2 family. You need $2 education. You need $2 loan. So we are taking these three columns in UNIV 2 data set, family, education, and loan. We are converting them into factors with the help of hash dot factor and storing into the same UNIV 2 data set with the column names family, education, and loan. So let me execute this. See now, family, education, and loan are now converted into factors. Okay, still we are having certain columns like ID, age, experience, income, zip, mortgage, CC, average. We are still in numeric or integer format that we are supposed to convert. So how do we convert that? Let us see in some time. So as I said, there are few more steps that we need to work out. That is unwanted columns like ID, zip, and all, which are no more required for us, or which are not at all required for us. We can drop them, remove them. Apart from that, correlation should be identified. So correlation function can be applied only on numeric attributes. Okay, so let us try to first segregate those attributes. So ID we are going to drop, don't worry about that. Age, experience, income, they are numeric attributes. So we are taking the uni2 data set. We are trying to subset from the larger data set 2, 3, 4 columns. 2, 3, 4 is age, experience, and income. Then zip we don't require, we will drop it. Family, education, we have just transform them into say factor. Family and education, don't worry about that. What we are left with is mortgage and CC average, which are again numeric in nature, so they cannot be converted into factors. So we will take as 8 and 9 columns. The remaining are CC, CD, online securities, inforec, and loan, which are stored, which are stored as factors. So now our job is to segregate age, experience, income, mortgage, CC average columns into a new data called uni2 num, that is numeric. Apply the correlation function. So in row 196 we have applied the correlation function. So once we are through with this correlation function, then we can identify the correlation between two attributes. If at all they are on a higher side, we have to remove any one attribute. We cannot continue with both the values, that is correlated values. So for that, let me execute 194 row. Subset of uni2 select is equal to 23489. What are these 2, 2, 3, 4, 8, 9 is? They are the column numbers, positions of the column numbers. We are subsetting them. We are not cutting from say we are not cutting them, we are not dropping them, nor we are cutting them from the uni2. We are making a copy of that. Still they are left in uni2, but a copy of them are stored in uni2 num. Okay, let us run the head function. You find that we have only these 5 numeric attributes in uni2 number. Let us run the correlation function. COR function is in R. In other languages it is CORR. Okay, in Python we use CORR for correlation. So correlation table always gives the output in the form of a table. Okay, so correlation function always gives the output in the form of a table. On the rows and columns we have the same column name, age and age, heading. So what we can identify by looking at the table values is uh, age and experience. If you look, it is 0.99. So any value above zero point 0.8 is suspiciously looked into. So here between age and experience we have 0.99. So we cannot have age and experience both the columns while building the model. We should have only one. So which one to drop depends on the subject matter expert. If it is a HR problem, we will keep experience, drop age. If it is like a banking problem, we will keep age and drop the experience. Okay. Then all the other values are minus 0.5, minus 0.13, okay, minus 0.05, so on so forth. So the closest something is 19%, followed 65% between income and CC average, but it is still less than 0.7, 70 or 80%. So we will not touch it. So what we have is the correlation value between age and experience is very high, above 0.8. So we have to drop any one attribute. We cannot have income and age, both of them going together. It is highly impossible. Okay, so we will keep age, we will drop experience, and all the remaining values are fine. So we will not touch or tamper any of the attributes. So, so along with ID zip, we will also drop experience, we will keep age. So that is what we are doing in row 200. What we are doing is we are, see, row space is empty. What does that mean? We are taking all the rows, column space minus of C, 1 comma 3 comma 5. Minus means we are removing. Which ones? 1 3 5. 1 is ID, 3 is experience, 5 is zip. So these three columns we are removing from I, okay, univ 2. We are storing again in the same data frame univ 2. Okay. So let us look at the dimensions. So we had 15 columns. Now we have removed 3. It should be 12. We have still age, income, mortgage, CC average stored as numeric. We have to convert them into factors, and the remaining all of them have been converted to factors. Okay, so we will stop here. I think it is too much, but I cannot stop. That's the reason I said that if we start, it is highly impossible to stop, because if we stop, then the crux of that will be lost. So I will pause once again, explain it. Okay, so not to worry, I will explain it again. So before that, what I want is, once I share you the code today, okay, you have tomorrow, day after tomorrow, and Sunday. We will meet mostly on first Monday. So these 3 days, I want each one of you to at least practice twice or thrice, so that you will know which function is what. Okay, if you don't understand, I am fine, because I am here to explain that. But I want you to have some knowledge about the function, okay, the inputs that each function takes, so that you start understanding the functions by yourself from the coming algorithms, not from this. Okay, so a quick recap. So what we did, we first set the working directory, checked in the directory function whether files are there in the working directory. They are there. We first copied the first file. We checked the dimensions. So we had 5,000 records and 8 columns. It's fine. The data is neatly segregated with only one flaw. Okay, one, that is the null values, missing values, that we can fill them. Then we went to this and we have, okay, that null values we have worked on. Then we will read the second table. We execute the dimensions. We have 5,000 records and 3 columns. The number of records of 1 and 2 tables are matching, except the number of columns. Don't worry about the columns, they can be combined. Here also we checked with the null value count. We have zero null values, missing values. It's a good sign for us. We went further. We copied the third data, that is about our credit card. What we found out, to our shock, is we have 60,000 records and 3 columns. Okay, and apart from that, there are some cell which are having missing values. So these are the two problems that we find within the data. So my first, see, this null values handling, missing values imputing can be done, so that we can keep it, okay, for our next thing. But the first thing is we need to merge the table. To merge the table, in the first two we have 5,000 records, and the third table we have 50,000 records. So quickly I will go to Excel and show you why there is a need to merge. Okay, because conceptually, if you understand, okay, any problem in the future, you will be able to do it without any help. Okay, let us say we have table 1. Let us say we have values like 1, 2, 3. Okay, let me center them. Okay, we have table 2. So we have something called, okay, let me write it somewhere. We have table 2 with some values, say 4 comma 5 comma 6. Fine. We have some table here, say table 3. Again, I am not bothered about the number of columns. I am only bothered about the number of rows. Okay. So I am not taking more than one column. I am only trying to take more rows. So let me take here 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Now let me also take table 4 with less number of values, say 21, 22, 23, 24, 25, 26. That's all. So we have 4 tables with different rows. Now I want to merge. What I do, I take table 1 and 2, I simply merge them. See, the number of rows are same. I am extremely happy with it. Now I go with table 3. I merge it with the first two tables. To my shock, what happens is that what happens to this place? So all these values will be stored as null values. Okay. To my shock, when I try to merge such tables with unequal rows, all these values in table 1 and 2 will be null values. This is one scenario. Or the second scenario is I need to remove all these values. I cannot remove values of 7 rows from table 3. Client will be extremely unhappy. So I have only one option, that is to merge. But when I merge, I have 3 filled in rows, whereas I have 7 NA rows. So with the help of these 3 filled in rows, I cannot fill the 7 missing rows. Okay, let me also bring in the table 4. What happens to these 3? Again, it will be stored as missing values. Okay, students. So this is the problem I am trying to tell. If we have unequal rows in the table, the tables with lesser rows will face problems, will be stored with missing values. Now, can I apply some function? I cannot. Okay, except on table 3 I cannot apply any sum function. Or if I combine all of them into a single table, okay, if I combine them into a single table, I cannot even apply sum function. So when I cannot even apply a basic sum function, what other, okay, latest functions can I apply? I cannot. So in order to overcome this issue, what we said is, okay, for each and every applicant in table 3 we have 12 months. Okay, let us say we have id uh, 1 to 12. Let me see whether I can copy this like this. Okay, so we have, like, okay, let me take this as months. This is id. So for id 1 we have 12 months of credit card spending. Let us call it as monthly spending data. We have some 12 months. Let us copy these values. Okay, students, please bear with me, understand. Okay, so let us say that these are the 12 months of credit card spending for id1. Similarly, for id2 we have 12 months and 12 months of credit card spending. So what I do is I take an average of this. So in place of taking all the say all the values, I simply sum and I make an average of these 12 values. So in place of all this, what I do is I simply make one row, that is id. This months is gone because there is no months now, we have only year, average year, and I take the value 16.5. So this is what I did in the third table. So for each id we have 12 values. Okay, we have taken the average and we have filled up. We went to the second id, 12 months we picked up, calculate the average for the 12 months, and we said that second id the average is 23. Then third, fourth, fifth, we got 5000 rows. That is what we achieved in the third table. Am I clear, students? See, I'm telling you as clear as possible. Okay. Oh, it is 9 o'clock. Okay, so give me some more time. Five. Okay, 5 minutes. Then we will call it a day. Okay, we will again work it out in the coming class. Okay. Then what I did. Okay, in the fourth, I, okay, did this with the help of tapply function. Okay, so tapply function is used to convert those 12 monthly values into one yearly mean value. Then we have the fourth table. We copied that and we did some casting. Okay, so previously I explained you, for each id we had four different rows of different types of accounts maintained by the bank and whether that person had that account or not. So what we did, we kept the id on the row. Each and every account we, okay, brought it to the column, and the value whether he has or not will be the value. Okay, that is called casting. Casting is simply reducing the number of rows and increasing the number of columns. Mainly we apply this when we have the input values in the columns as zeros and ones. Okay, so this cast function is present in reshape package. Install this package and apply the cast function. Once we do it, then we merge all the four tables. What we get is 5000 records and 15 columns. So there are some null values, some columns which we don't require in modeling, some correlations within the columns, and because this is a classification problem and the data is having null values, and also what we have is the algorithm is decision trees. So for say classification and decision trees, we need to have each and every column in the factor data type, but we have mostly either in numeric, integer, or character. So characters can be converted into factors directly. The rest are numeric and integer. So as I said, numeric or integer is of two types. One is those columns with less than 10 levels or categories, those with more than 10 levels or categories. So we find that family, education, and loan are the three numeric columns with less than 10 levels, whereas the remaining all have more than 10 levels. So less than 10 levels, we can again directly convert with the help of hash dot factor function. Okay, and we will deal with how to convert the remaining numeric columns into factors. Okay, so with this I will stop the session. Immediately I will send the notes to the Blackbucks team. They will share the same with you. Okay, once you get the data sets and also the code, please practice at least twice or thrice so that you will get some hands-on experience. So please give your attendance. So I am logging off. Thanks for joining. See, as we are learning for the first time, it will confuse you to some extent, but don't worry, it will happen to you. It has happened to me. For everyone, it's common, but don't panic. You are on the right path. If you are struggling to understand, it means that your brain is struggling, not you, to understand. But once it understands, then everything will be fine.